interwebs, welcome to Let's Fix Computers. I'm on selfie cam on my mobile at the moment because I want to show you some stuff. We're going to be doing an experiment today with lighting setups. So firstly, let me give you a quick tour on how my shop is lit up and what I want to do with it. So here's the problem. That guy up there is broke. So my shop has this arched ceiling, and as you can see, there's a batten strip light on each side. However, that one has failed. Now this happens. These strip lights do fail on occasion. Let me just climb up and show you. Get on top of counter. There we go. So these things do fail now and then. So you can see where this one is not illuminating properly versus that one. Ooh, flicker. And now and then these tubes fail and you put another tube in. However, they're not very good. And I did say the last time one of these tubes failed that when one failed, I would replace it with something better. So the last time this happened, I bought this LED batten strip light here. Yeah, there's a lot of flicker there. That is now the main bench light. And it works very well. It provides plenty of light, which I'm quite happy with. However, the problem is firstly, it's a bit of a greenish hue. There's a bit of a greenish tinge to this light that I don't like. It's although it's nice and bright and white for the workbench, it's really unattractive. And the other issue is that flicker, man. And you can see it big time. If we look at a spinning fan, can you see the chopping on that fan? Look at that banding, look at that rolling shutter. So that's the problem. So what I did was I was watching DIY Perks, and he was building some DC lamps with this here LED tape, this exact stuff. This is the stuff he recommended, brand new. The LEDs on this tape have a CRI, so a color rating index, of 95 or up, which is super good, which means they give a really clean, really nice white light. So what I want to do is, I don't know if this is going to work or not, but I want to take this roll of LED tape and put it along the top there, where that strip light is, and use it as the main illumination in the room. And I'm hoping that that's going to have enough light output to provide a general wash light for the room in a really high quality daylight white. That's the objective here. Okay, right, I have taped the LED tape down along this rail here. And as you can see, I've run it the full length of the shot, which is, I don't know how long, like 4.5 meters, something like that. Okay, here we go. Kazap! Phew! Woo, lad. God, that's not bad, is it? Whoa, look at that. Let's mount this somewhere. Right, so there it is, compared to the strip light. Flickery strip light. Beautiful white aura, look at that. Oh, that's gorgeous. I need more of that in my life. Actual lumen per lumen, it's hard to tell, but it looks fantastic. Oh, that's gorgeous. I need it. So more testing. This is the LED strip at full tilt, so that's 5 amps. And according to just a cheap light meter for my phone, that's putting out 300 lux to the desk on its own. I've got the other lights on at the moment, however, that on its own is putting it down 300, whereas apparently the strip light on its own up there was 100. So yeah, these things are obliterating the fluorescent tubes for overall output. The only problem is at the moment, the mains adapter that I've got hooked up, as you can see, we're currently running at 62 watts. The mains adapter I've got hooked up to it at the moment is only rated for 4 amps. So sadly I can't leave them on because this thing will probably blow up. So we're just waiting on the brightness controller. Okay, so more bits have arrived and it's time to do some testing. So I've purchased these aluminium strips. Now this is just known as aluminium angle. It's extruded aluminium angle to be precise, because what they do is they have a little L shape and they push liquid metal through it and it comes out in an L shape. So yeah, this stuff is really cheap on eBay, and as you can see, it literally is just a 90-degree bend.
and it's really good for mounting LED strips and stuff. This is going to do two things for me. So firstly, this gives me a mounting strip that I can mount my LEDs on and then have them be mobile, because I don't want to stick them to the ceiling or to the wall or to the rails, because then they're difficult to remove. Whereas if they're mounted on these strips, then I can take them off and I can move them, or I can move them up and down, or I can switch sides. I can do all kinds of useful stuff with them. And the other function of this is it doubles up as a heat sink, so I don't need to worry about the LEDs heating up. Because while I'm running them at low power, they won't produce a huge amount of heat. However, because they're going to be on all day, every day, we do want to extend the life of them by giving them some cooling and just not having to worry about that. So we're giving them a heatsink and a mounting strip in one fell swoop here. So let me grab my, where's my reel gone? Okay, so I've removed the LEDs from the ceiling again. So now the way I'm going to do this is, if this is the rail that I'm going to be mounting them on, I want the strip to overhang the back of the rail, so this bit that hangs down is not visible from within inside the shop. So you guys are looking at the back of the rail and the interior of the shop is down here. So then the LEDs are here pointing upwards and the rail overhangs the back. So I'm going to mount them this way up, and I'm going to have the input power connector this end, and I'm going to have an output connector at this end, so I can daisy chain the strips together going down the shop. And the daisy chaining will just mean that it's easy to wire them all up. So let's remove it. And so what we want to do is put a length of the LEDs down this strip, like so. Now, looking at the cut points for this one, these are not going to be precise. I'm just going to do this by ear. Yeah, so the strips I've got are 800mm long, so they're just under a meter. And the cutting points of the LED tape, which you can see from these little copper dots along the way. Let me switch cameras. So I want to have these markers at each end. So we're not going to get full coverage, but to be honest, I'm okay with that. So at the moment, for my first length, that's where I want to cut it. So there we go, it's done. I always get nervous when it comes to actually cutting LED tape like this, because you can solder it back together, but I don't know, I never like it. Okay, so now I want to mount this on my thing. Now, as you can see, the sticky backing tape is not really staying on very well, but I want to, there's two options I can do here. Now, in DIY Perks left the backing tape on and hot glued his down to there, so there was additional insulation. But because this is all a bit ripply, I don't know if I want to do that or not. Let's see if I can straighten that out first. I'm just going to hold that flat and just try and straighten out the ripples. I don't know if that's working. Right, that has done not a huge amount. My other option is to just take some cheap lecky tape and put some electrical tape along the top there. I don't need to worry about the heat, because we don't have an enormous amount of heat coming out of these. This isn't like a CPU or anything. It's not going to melt the tape, it's just going to warm it up. Because if I stick some electrical tape to the top of that, I can then just remove the sticky back and use the sticky back on top of that. The worst thing that I will do is waste a load of electrical tape. Okay, so there's my insulated aluminium angle. So let's flip that around so it's the correct way around for my orientation. So now I'm going to peel off the sticky back of my LED strip and lay it down like that. And then it'll be nice and insulated against the electrical tape. So as you can see, we have got a little bit of some gaps. We will have some gaps at the end there. There's not a lot I can do about that just because of how the LEDs are spaced. If I move it all the way up to the end there, there's just not quite enough length. Well, there was probably enough length, but yeah, we're just going to put it like that. So that's going to be centered. So that's going to go about there. This is incredibly professional, as you can see. Right, and now please allow me to blow out your eyeballs. There we go. So that's what we've now got. We now have a nice, super bright LED batten. Beautiful. It's absolutely gorgeous, and we don't need to worry about that overheating. Okay, so now in order to daisy chain the lamps up, we're going to stick a connector on the end of it. And I bought what's just generally known as just project wire or hookup wire for this. And this is, I don't know what gauge it was. I will link all the stuff that I purchased in the description for this video, so it'll be down in the description below. But this wire looks suspiciously spindly, but it is rated for 7 amps, if my memory serves. No, like 11 amps or something like that. So apparently it can take it. And I did actually put it to the test as well. I put this wire in a dead short on my power supply at 350 watts, and it just tanked it, no problem at all. Whereas the other wires, by comparison, these are the crocodile clip wires that I use on my power supply for hooking stuff up. Look at the comparison. Look how weedy this stuff looks compared to these croc clip wires. These guys, these top out at about 40 or 50 watts. They start warming up quite concerningly. So yeah, you know, the thickness of the wire isn't always representative of how much beef it's got. This is one of the reasons why I wanted to build this myself. I'm learning so much in this. So I'm going to leave myself a generous amount. So let's say, let's try and make it an actual length. Let's say, what, 10 centimeters for the fly leads? But then there will be, yeah, that would be, let's make them 10 centimeters. That allows for off-cut and stuff like that. So let's strip the wire. There we go. And I'm going to attach this to the connectors first. Now these connectors, these are Molex series connectors, and they are 3.96mm pin pitch header plugs. Again, links in the description, etc., etc. Now I chose these. I should have used Mini Tamiya or something like that, but I'd already purchased these by the time someone said, why not just use Mini Tamiya? Because for the record, Mini Tamiya is what I've got. That's these connectors that I'm using here, the yellow ones. That's Mini Tamiya. And it's quite a handy connector. It's very simple to use, quite high current handling. But I bought these pin pitch headers, and these things are rated for 7 amps. And as you can see, it's a nice little just connectable header connector. So yeah, so we're going to attach these. Right, so because this is the power out, we want to put the socketed end on. So let's grab one of these. Now I don't actually have the crimp tool for this, so I'm going to ghetto it. I'm going to solder in, which you know you're not supposed to do, but who cares? Who's going to stop me? So I'm going to lay that. I'm going to bend that back a bit. Lay that in there, and I'm just going to fold the things over. Just going to self-crimp this. Pliers. Whoops. Obviously, if I had the crimp tool, this would be a lot easier. But, you know, I don't do this all the time, so I can't be bothered to buy one. So I'm just going to make a pig's ear of this. I literally just needed just enough grip on that cable so it doesn't fall out. That'll do. It's not going to fall out. So now we're going to get the soldering iron and just put a blob of solder on that to hold it all in place. There we go. I've just fed that in there. And we'll just do a quick test run on this so you can see how it works. Now, are these polarized? They should be. So that seems to be the right way up to me, so the clip is on top. So we're going to make that our live pin and that our negative. So let's slot you into there. There we go, and that's now in there, nice and tight. Nothing hanging out the end. And that can now plug in. And we have a 7-amp hookup. Nice. So now we've just got to rinse and repeat that for the other side. I really like these little connectors. I need to find a more compatible one that has a nice cheap crimp tool available for it, because I want to get into building projects, which is also why I wanted to build these lights myself. And trying to crush these with a pair of pliers is pretty horrendous. I'm sure there's someone in the audience cringing right now. There we go, that'll do. Normally, of course, you don't solder stuff like this, you crimp it. However, because I don't have the crimp tool, I'm cheating. Oh wow, I misjudged that length pretty bad. Oh well. Right, now I have to hope that I'm not going to melt my insulation, because I think I'm going to melt my insulation. So let's stick a little bit of solder on those pads to tin them up. I'll solder this together and then I'll quickly do a continuity test across it just to make sure that we haven't damaged anything. That's going to suck if we have. And I've just tinned up the ends of these wires, as you can see. I think I'm going to trim them super short, actually. I'm doing this super cack-handedly for the sake of the camera angle, so if you're wondering why I'm cack-handed, it's for the camera. Okay, right, continuity test. Beep beep. Good, we haven't gone through all the insulation. Okay, so that's my first LED batten or LED strip done. Now, I'm still using the really ropey hookup cable that I was using to test with. However, because my LED dimmer hasn't arrived yet, I don't want to redo these cables because, yeah, as I say, don't know what I'm going to put on the end there yet. But yeah, so this strip on its own is consuming, this is at 12 volts and 0.9 amps, so 900 milliamps. And if I turn the amperage down a bit just to dim it, let's take it down to half. So there we go, that's 450 milliamps. Then that's 20 milliamps. And that's 100 milliamps. So yeah, it's even at 100 milliamps, they're still very clearly on. Yeah, that's pretty cool. So yeah, dimming wise, yeah, that's cool. And each one of these is not consuming much power. And let me give it the beans again. So full brightness. I'm going to leave that plugged. I'm going to leave that running for a bit and just see how warm that gets and where the heat goes. So I'll see you guys in a bit. And in terms of in-lamp losses, because I'm concerned about losing voltage across the strip once I've daisy-chained some of these up together. However, again, we're at full tilt here, and I'm actually dropping, as you can see, I've actually only got just shy of 11 volts coming into the strip. So I'm actually dropping a fair amount through the hookup cables I'm using, which is probably the really crappy crocodile clip cables. Those are the ones that I mentioned earlier on. And at the far end, we've got, coming out of the strip, again, just shy of 11 volts. So once we've daisy chained 4 of these together, I don't think we're going to lose more than 1 volt or so down the entire length of the daisy chain, which means we should get really good brightness across the whole length. And if we drop a little bit of brightness by the end of the cable, I'm not too heartbroken about that. You have to drop a fair bit before there's any perceivable difference in light. Okay, right, well, I've left these things turned on for a while now, blinding me from across the room, and I've been checking the temperature on them, and the indicated temperature using my infrared thermometer here doesn't seem to be going anywhere past 30 degrees. Wow, I just put that exactly down in front of there. Well, yeah, that's the infrared thermometer I'm using. It's a cheap Amazon one. Anyway, yeah, these things don't seem to be going past 30. The batten is warm to the touch, but, it's not remotely uncomfortable or anything like that. Power consumption is still exactly the same. So, yeah, this seems to be working absolutely fine. I think I'm ready to make a whole load more of these now. So I'm going to put more of these together and we'll daisy chain them up. And in case anyone's wondering, the bottom of the tape looks like this. So it's all white and insulated except for the copper spacers. That's where you'll short it out. However, we've got the double-sided tape over that, and then the electrical tape on top of that, which is how we're avoiding shorting anything out. And the solder joins are actually quite frequent in the tape. I'm surprised by how often they are. So I desoldered it from there. So there's 28, 29, 30. Oh, there you go. It's 30 LEDs per length, which is interesting. Now for these ones, where we're going on to the male end of the plug, we're going to do this slightly differently because obviously we're not crimping to these, so we're going to solder to those ends. And I've got some, I have actually got some, if I can find it, there it is. I've got heat shrink for this, so I'm going to put just a little bit of heat shrink on the ends of these. And as per last time, I'm just going to trim them short, just so there's the smallest solder blobs possible on those bare ends. Because obviously, these I don't care about. These are nice and covered up, so there's no metal exposed. However, these bits will be exposed on the LED strip, so I want to keep the amount of exposed metal down as low as I can. No problem, no short circuits. And continuity test. I'm going to keep being really strict about my continuity testing because we're putting 60 watts down this thing. I don't want to short out 60 watts. Yep, all good. Alright, so that's my second batten made up. Now we've got an input end here. No, sorry, that's the output end because it's socketed, so you can't accidentally touch the live end. And the input end has got a plug on it. So now that is going to hook up to the output from the other one. So these two will now daisy chain together. So I can have them both sitting directly next to each other up on the rail, and that's going to work nicely. So I think, well, actually I can just plug those both in here. So let's do a quick test setup. Then I'm going home for the day, and we'll do the other two tomorrow. My bench is a frickin' mess right now. Alright, we're all hooked up, and we've got this bit up here in the top left of your screen there. Those are my two daisy chain connectors that are now connected together. And we've got 12 to 12, negative to negative. So let's turn on the power supply and let her rip. Skadoosh. Okay, right, let's see what the draw is now. So firstly, I'm going to turn that, well, yeah, let's see where it goes. Oh, that's interesting. That's topped out at 1.35 amps. That's less than I was expecting. They are visibly the same brightness. Okay, well, it is what it is. I don't know what that means, however, yeah. Yeah, unless we're getting losses somewhere. Well, we're probably getting some losses in the cables because of poor connection. Because I can jolt those and that, I swear that's twinkling. Yeah, we've got poor connections in the cables here. That's probably got a bit more to give. However, the important thing is they're both working. The daisy chain connectors are working. So all I need to do is make another two of these now, and I'll have about 3.5 meters worth of LED strips daisy chained up and ready to go. Now at this point, I did a test with 3 of the strips hooked up, as you can see. And when I was recording this section, as you'll see in a moment, we had a slight bit of flashing that just appeared at random now and then. And I was talking here about how I'm not sure whether it was the power supply I was using, whether I was overloading it or what. However, it actually turned out to be just, again, that terrible input hookup cable that I was using with the horrible mess of connectors on it. After I replaced that, this problem disappeared completely while using the same connector. So yeah, that's what this was all about. This is why I'm doing these nice custom daisy chain connectors. They make a big difference. Don't twist and tape and do dodgy connections. It'll just hurt you later on. I recorded a detailed segment on exactly how the dimmer works, right down to the kind of output it gives and why it doesn't produce flicker. However, in order to keep the length of this video down, I've moved that entire section into a separate video, which will also be linked down below. So if you're interested in knowing how the dimmer works and why it doesn't cause flickering where other dimmers do cause flicker, then check out that video and I explain it in quite vivid detail. Okay, so we've now got 3 battens per side. So we've got 3 there, and we've got 3 over there. Flickery AC lighting, nice smooth DC lighting, look at that. So, the lighting in the shop is fantastic now. I mean, with the bench light off, we still lose a lot of light across the top of the workbench, but I'm going to sort that out another time. That's not what this particular one is about. However, around in the general shop now, we just have vastly more light. It's a very flat light. It's a very cold light. It's not very cozy. I wouldn't use it at home. However, I'm not here to be cozy. I'm here to be able to see what I'm doing. So yeah. Then if we move over to here, we've got our dimmer in line on this one. So this side now, as you can see, we can now dim this down to almost off, but just visible. And then we can whack that up to full. And at the moment, I'm just running them all at full brightness, and I probably will all the time, in all honesty. There's not really any need for me to dim them. So the power supplies I'm using are just two 12-volt 4-amp bricks that I had lying around.
You can buy these kind of power supplies on eBay, and then I've just chopped and wired them up onto my panel connectors and into the daisy chain. Each side is consuming about 42 watts. I think the other side was on about 40 watts, but that one's a different power supply. There's another one of my ropey power supplies there. The other one seems to be running a little bit more efficiently than this one. 40 watts aside for this amount of light is pretty decent. I'm happy with that. So the last thing left to do now is to wire them in so they're operated from the light switches, not by having this multi-socket perched up on the railings. Okay, last piece of the puzzle is to get it so these things are turned on by the light switch. So what I need to do is get them powered from the same source that the strip lights were powered. So here's one of the old batten strips. I've removed the tube already. And what I'm going to do is I'm going to take the wiring out of this, and I'm going to connect the wiring to a junction box. And into that junction box, I'm going to wire this multi-socket. So we'll take the plug off and we'll put the plug into the junction box. So we'll end up with this multi-socket sitting up here that's wired into the lighting circuit. And then I can take the power supplies up there and I can connect them directly into the multi-socket, and the whole thing will be powered from the lighting ring. And that means that I can change the power supplies without having to chop and change stuff. So if a power supply goes pop, I can just put another one in, and I don't have to modify any cables. And I can also plug in additional lights up here if I want to at a later time. So let's open this thing up. I've already taken the screws out just for ease because it's a bit pokey up here. Let's move that. So in here, we've got a magnetic ballast, which was very buzzy. There's the starter. It might be that that starter's gone on the other one, who knows. And as you can see, we've got an AC cable that comes in, goes down the side, and up to there. So we're going to remove that and plug it into my junction box. So let's do that. There's my junction box, which goes down to the thing. Bit sketchy, not a big fan of terminator blocks like this. I was hoping this one would be a bit better. When I saw 4-terminal junction box, I thought it would be, like these were common together or something. But whatever, they're in there quite securely, and this is going to have a cap screw down on top of it, so there's going to be no mains voltage that's exposed, and everything's all nicely tight in there, so nothing's going to fall out and there's nothing exposed. And also, just in case anyone is wondering, this whole system at the moment, this whole wire, this circuit is double isolated. It's off at the light switch and at the fuse box, so I am taking careful. There's no power here at all. That light's coming from a battery light. Cool, let's keep going. Alright, and that's that. So, a lot of excess cable. So there's the power brick, that's plugged into the end of the daisy chain up there. That then goes into my 4-way. The 4-way, I've buried all of the extra cable I've got. And then there's the junction box there. So that gives me, everything is nice and hooked up, everything is nice and isolated, can't touch any mains electrical stuff, and the whole thing is still grounded. Up to the DC out, of course. There's no ground coming out of here, but it's 12 volts, so you don't need it. But all the nasty stuff, all the high voltage stuff, that's all grounded. So, happy days. And there we have it. The entire setup is now finished. So I've got 3 strips per side. I've got the bench light off at the moment just to make sure that there's no flicker ruining my lovely smooth DC lighting. And I can come back in here to the light switches and I can go pop and switch it back on again. Beautiful. Thank you very much for watching, everyone. I will see you all next time. Bye for now.